Hello guys, myself Atanu, and I will be training for the Fabric, training your Microsoft Fabric only for the data engineering purpose. And so let me give you my introduction first. So I work as a senior data engineer in a MNC. There I worked with multiple tools and technologies related to data engineering like GCP Cloud, Microsoft Azure Cloud, and alongside I have worked on the Snowflake. I have worked on multiple, other tools like Fibertran and DBT, and then I have shifted to Microsoft Azure, and then around 2 years I'm working in Fabric. So anyway, so as Fabric is very new to the market also, so we are trying to adopt as much as we can. But as I am already worked on multiple projects on the Fabric, so I can help you on multiple things which is hands-on alongside with the theory part. So let's get into the topic. Do you have any question regarding our course? What about the introduction or about me? If you have any question, you can just feel free to ask me. You can stop me in between, no issue. Can we start? And just let's start on the data engineering and the Microsoft Fabric. So first of all, you have to understand what is data engineering before coming to all those, new tools and technologies like Fabric. First of all, what is data engineering? So data engineering is totally methodology where we ingest the data from multiple sources. Okay. It can be any sources. What if you can think of Excel? Yes, we ingest our data from Excel also. If you think about some cloud system, that also we can do. If you think about some database, yes, we do ingest from there also. If you think about some real-time streaming data, that also we do. Wherever the data will exist, from there only ingestion of data will take place. Okay, that is data engineering. I'm not talking about Fabric. Okay? Kind of we are gathering the data from multiple sources and pushing into one place, and then we are doing some kinds of cleansing. We are doing some kinds of transformation, and then we are making the data for business ready. Okay, so that this whole process, like getting some junk data, making it usable to make it as a business specific data, this whole process is called a data engineering. So now in this data engineering process, to do all those necessary steps, you have to have some platform which can help you to build. So for that, there are multiple tools available in the market. So here, that kinds of data engineering tool is Microsoft Fabric. So Microsoft Fabric is providing a platform to do all those data engineering related tasks and will help you to focus on the development of the business things like ingesting the data and all those things. Right? Whenever you are doing something, if you're trying to create a Word file in your laptop, then what do you have to do? You have to have a laptop first. That is called your infrastructure. You have to have the Microsoft Office should be installed on your machine, right? And then you will go to the Microsoft Word app and you will create the file and you will save it. So before that, two infrastructure related steps comes into picture. One is having a laptop with all the necessary configuration, and second is the installation of the Microsoft Office. These kinds of infrastructure steps also we needed to do for doing the data engineering. So now these kinds of infrastructure related steps, Fabric is helping us to give you a platform. You just focus on your business level application development. No need to think about infrastructure, no need to think about scalability, no need to think about security. All those things Fabric will take. Okay. So in one word, Fabric is a platform which will provide end-to-end solution of data engineering. Okay. So now coming to the architecture and key components. Before that, are you clear with the data engineering? What is data engineering? Because this is the fundamental concept you have to understand before starting up any data engineering class on any tool. Now already I told now what is data engineering. Like it prepares the raw data from multiple sources, doing some cleansing, doing some transformation and putting into some places which business can utilize. That is the same thing is written here. So now in the data engineering world, there are two terms to do the data engineering. One is called ETL, another one is called ELT. Okay, what it stands for? ETL stands for extract, transform and load. ELT stands for extract, load and transform. So you can see, right, this L word is just tweaking. First time L is at last, second time L is in between E and T. What difference it is making? So to understand this, you have to know a little bit of history of the data engineering. In earlier 2000, the data engineering was also there. But for doing the data engineering, company was investing for multiple types of data centers. Like they are creating their own infrastructure. They will create their own data centers. On top of that, they will install all the necessary softwares and then they will be able to do the data engineering. At that time, cloud was also, introduced. But at that time, cloud storage was very, so that is why what people used to do, use some ETL tool which will extract the data, which will transform on the way, and then whichever is actually business useful data, which business people will consume, only that much chunk of data they are going to store in the, like, let's say the cloud location. Okay, so that they will not be paying some extra fees because of pulling the junk data and doing the transformation and all. For those, they don't wanted to pay because it was very expensive storage. So that is why they wanted to push only which was necessary at that time. So for that one, extract, transform and load ETL process was followed. Like first extraction using a tool, transformation using the same tool, and then load. So only the loading part is the storage part. Okay, L part. Only there the data was getting stored. Okay, so earlier days ETL was majorly followed. Even now also few companies are following the ETL still. But in modern days, the cloud, boom is too much, and there are multiple, competing cloud companies has come, and they are providing very cheap rates of, cloud storage. Not only many company, every company nowadays cloud storage is very cheap. So that is why the organization were following the ETL. Now they say that why they will put the extra, transformation load in between the while ingesting the data inside the tool itself. They say that let's have all the data, let's bring everything, whatever it is, even it is junk data, that is fine, let's bring everything into our cloud layer first. Okay, that thing was also happening earlier, but then store into the cloud, that terms it comes to L. L means store the data, extract and load. First load it, and then once the data is landed into cloud storage, then people say that on top of that we will do the transformation. So now earlier what it was doing, on the way, while bringing the data from multiple sources to cloud, at that time transformation and the cleansing was happening. That is called transformation, this T term. Because the reason was because the cloud storage was very expensive, and company wanted to have very less budget of this cloud storage. At that time cloud was not very famous, so that is why ETL approach was followed. But nowadays, as cloud is very cheap, any company are going ahead with the cloud storage first, instead setting up any their own data centers. Okay, so that is why currently people are following the ELT approach. Are you clear with this? I'll just give a small introduction of this cloud, because most of the people know cloud, but I will just give another introduction. So earlier initially I gave an example that infrastructure, what is called infrastructure, like to create a Word file, you must have a laptop first. That laptop must have a proper configuration to run the Word file, and then you have to install the Microsoft Office to open the Microsoft Word application. These are the prerequisites should be there to create a Word document, right? If someone doesn't have laptop, if someone doesn't have the Microsoft Office, no one will be able to create a Word file. Even they cannot read the Word file also. So this is called infrastructure. So now relate it with our current scenario of the data engineering. To do the data engineering, company has to have a platform first. What platform? It should be a big data platform where multiple machines, high amount of RAM, high amount of storage, high amount of processing power is required. So what company used to do earlier? Company used to buy all the machines. They used to set up their own data center where high RAM will be there, high storage will be there, CPU power will be there on that data center. On top of that, our developers will sit on top of that, and they will run their ETL job. Correct? ETL jobs mean for using that platform, company whatever they have set up. Now company, what they found? Company are finding that maintaining a data center is very complex task. They have to invest lot of money. They have to have a separate kind of headache for that to maintain that data center. So that is why cloud companies are coming to picture. Cloud is saying that, hey, if you wanted to build a data engineering platform, then you don't have to do any kinds of infrastructure. It is zero infrastructure. Company saying, come to my platform, go to this website, okay, and then do a sign up with your email, and then you are good to go. You will get lots of infrastructure. If you are using for data engineering, if your data engineering platform, let's say sometime, what company used to happen, earlier days where they had a data center, what they have to do, let's say 128 GB of RAM in their current data center capability. But later they realize that 128 GB RAM is not enough. They have to have a 256 GB of RAM. What they had to do? They had to again upgrade their data center to do the 256 GB of RAM, which requires lots of time. Second, which requires lots of budgeting again. And then again, maintenance, all those things comes into picture. But in this cloud world, cloud company are saying if you wanted to scale up, if you just click on that how much RAM you want, you'll be good to go. Immediately that 250 GB RAM resource will be available in just a second. If you want, no, I don't want 256 GB of RAM now. I want to 128 to downgrade. Immediately it will be done. If you want, instead of 1 terabyte of storage, if you want 10 terabytes of storage, then just a click and it's good to go. So these kinds of feasibility now companies are getting. Cloud is definitely expensive than a data center, but in terms of maintenance, in terms of complexity, in terms of doing all those things, it's very hectic process. So that is why companies are finding it very cheaper in terms of doing all those things. That is why most of the companies are going to cloud for their application development, for their data engineering, for everything. So this is a brief introduction to cloud. Alongside, cloud is also very famous because let's say your some system got failed, one of your hard disk is not working, then who will support? So that kinds of support also cloud companies are providing. If something got broken, cloud companies are available 24/7. Immediately they will support, immediately they will help you out to resolve that issue so that business won't impact. Then there are multiple reasons like this which will be helpful for companies to move ahead with the cloud or anything. For our this case, it is data engineering. I hope everyone is clear. Okay, so now going to a little bit specific. Earlier I was talking about generic cloud. Like there are multiple cloud providers. Popular cloud providers are there like AWS, GCP, Azure. These are the major three market holders who are having most of the market capability of all the cloud market. First of top market cap is having AWS, and second is Azure, and third is GCP. And then multiple things comes like Oracle and other things. So now we are specific to Azure now. Currently we are focusing on Fabric, and Fabric is totally based on the Microsoft Azure cloud platform. So this cloud platform is a public cloud platform. Why I am saying this public word? Because company whoever was setting up the data center, I just told a story, right? Company used to have a data centers. Those data centers, it is not necessarily that those data centers will be available for all the publics. From any location, you won't be able to access it. Some data centers was accessible, but some data center wasn't. So what are the data centers was accessible from anywhere in the world? Those are called the public. And what are the data centers? When I say data center, it's just like you just consider the data center where the setup is there. What are the data centers is not accessible from throughout the world? Those are called private. Why it's private? Because company is setting up only for their own purpose. They don't want it to be used by anyone else except the company. But Azure, AWS, GCP all are public cloud platform because they have set up this business for throughout the world. So now Microsoft Azure is a public cloud platform. It's a scalable, any kinds of scalability in terms of compute, in terms of storage, in terms of RAM, everything is scalable. Global infrastructure, like they have the data centers throughout the world in every most of the countries, almost all countries they have their own data center, and from there they are maintaining this cloud. So pay as you go, wide range of services that I will go one by one, but as a holistic manner you can just say that it has access control. Like even if it's a public cloud, not everyone can access it. It has a very, very good access control system. There are multiple applications they have inside the Azure platform to control the access based on a role, based on multiple places. They have a very secure platform. They have multiple layers of security. Third thing is, what is this? They have multiple types of databases. They have multiple types of Azure storage. Inside Fabric, it is OneLake storage, Azure SQL database, Cosmos DB, multiple types. Whatever types of storage is present in current market, a structured table like SQL Server or any kinds of database, you can use it here. You can install inside the VM or you can use it as a service. And alongside, even if you are an application developer, you wanted to use some, NoSQL database, then you have those also. If you wanted to store your, unstructured data like photos, videos, and any kinds of text file, that also you can store it there. Everything is there. And alongside, the major part is it support the IaaS. IaaS means infrastructure as service. That is another layer of discussion. I will just come back, but I will just give you a brief. Like, let's say you are creating a Fabric platform, right? To create the Fabric platform, you have to do some steps, right? After sign up, then you have to create a resource, and then you have to do some access control on top of that. There will be some other tables will be created. Multiple things will be done. So those things also can be automated as a part of infrastructure setup. I'm just giving an example. Inside Fabric, all those infrastructure setup you have to do, those also can be automated. Those processes are called infrastructure as a service. There is multiple tools available. Like if you have heard about a tool Terraform. Terraform is a very popular IaaS service. Like those similar tools are also available inside Azure. Okay, so everything is available in the Azure. There are plenty of services available. So here in this session, we will be majorly talking about the Azure data engineering with Fabric. Majorly the data engineering related services we will be covering. And inside Fabric, it is not a service. It is called item. So only those things will be covered. Now coming to the actual topic, introduction to MS Fabric. So what is Fabric? So it's a unified SaaS analytics platform. I already told SaaS means software as a service. This is Fabric is a software, right? This software, you are getting it as a URL in the browser. Fabric solution, you will be able to access it through a browser only. So that is the beauty of cloud. And this platform supports storage, which is called OneLake. It has the computation using Spark. It supports Synapse, which was the Microsoft Azure. Not only data warehousing, it supports multiple other things also, but majorly it is for data warehousing solutions. The data factory, it's an integration tool, and the Power BI, which is for reporting. So everything is integrated inside Fabric. You don't have to work with multiple services. So Fabric is integrated with everything inside. Okay. So now the question comes, why I will learn Microsoft Fabric? So because Microsoft Fabric is the latest tool by Microsoft. Whatever the Microsoft data engineering platform is currently having, like Data Factory, Azure AWS Gen 2, and Databricks is not, Azure's property. But apart from that, Power BI, everything, whatever is there, that will be slowly becomes the legacy services in coming days. Microsoft is not going to put any kinds of upgrade on top of those services. To make everything in one place, Microsoft has released Fabric, and whatever in coming days, whatever the Microsoft will release the update, and Microsoft will work on majorly on the Fabric. Slowly, company will migrate their all data analytics platform, which is present in the Azure, inside Fabric. Okay, to sync with expectation or market standard. So now, the thing is that Microsoft Fabric is the latest tool. Everyone wants to become sync with the current market tools and technologies. So that is why Microsoft Fabric will be in future. There will be no data factory in coming years, or even if it's there, it will be as a legacy version. So wherever companies are hiring the data engineers, all the data engineers must have to learn Fabric. If they are working on the Azure, they have to also run Fabric. Even if you are not learning, if you are not working on Fabric, they also have to learn Fabric if you wanted to survive in the coming days. Second thing is, Fabric is very new tool, and companies are searching for good data engineers in Fabric, and they are not able to find it. Me, as an example, I am working in an MNC company, and in my team, is that truly I'm speaking, I'm not getting, data engineer. So that is why it is very, very important to learn Microsoft Fabric very well, to understand what Microsoft Fabric is doing, how it is working, and all those. I hope I'm clear right here. The reason behind learning. The third thing is the data factory, data engineering, real-time analytics, and Power BI. These all four, which are present as a different service in the Azure world, all those things are integrated inside. For data engineering related, majorly the data processing start, the computation task is done by the Spark. That Spark is also integrated inside Fabric. For real-time analytics, event stream, event hub, whatever was things was there, that is also integrated. Power BI, I already told, and data factory. So these are the major components of the data engineering inside Fabric, which was present in Azure also. But these are the major components where you will get lots of new features in Fabric, which you will not get in the current Azure world. So just giving a little bit of in-depth components that are present inside the Fabric. Like, let's say Data Factory. Data Factory is an integration tool. This integration tool, as I already told, which will integrate with multiple systems, and it will give you a flexibility with no code. Like, you don't have to write any single line of code, integrate with any kinds of systems. Data Factory has plenty of connectors which can connect to multiple types of ERPs, multiple types of CRMs, multiple types of databases, anything. Data factory can connect with most of the things that are present in the market. Similar thing, Dataflow Gen 2. Dataflow Gen 2 is also kind of a data integration tool, similar like for Data Factory. But Data Factory and Dataflow Gen 2 is difference is Data Factory can only pull the data from one place and push into another place. But Dataflow Gen 2 is one step higher. Dataflow Gen 2, alongside with the pulling the data from one place to another, it can do a transformation also with no code. It's just a UI manner. You can just do a click and the things will be done. Okay. So this is a data factory. This is a very, very important component inside Fabric. Now comes to data engineering part. Under data engineering, there are multiple things. One is one leg, which is a storage layer where actually the data gets stored. Okay. That they are calling is one leg, but in backend, it is a ADLS, Azure Data Lake Storage Gen 2, which is the Azure major storage layer. That is also actually working in the backend, but they have changed lots of things on top of the ADLS. That is why they are calling it one leg. That kinds of in-depth information I will giving in the coming classes. Lakehouse and warehouse. The Lakehouse is the newer addition in the Fabric. What Lakehouse does? Lakehouse can store any kinds of unstructured data as well as structured data. But everyone knows, right? Warehouse is a structured, majorly the structured data. It can store semi-structured data also sometimes, but majorly warehouse are storing the structured data. Okay. But Lakehouse can store structured data as well as unstructured data. What is structured data? Structured data means an Excel file or a database, whatever data are coming, those are structured. When I say unstructured, the unstructured is a image, a normal text file, a video, or a Word document. Okay, those can also be stored inside Lakehouse, which can't be stored inside warehouse. Okay, so these are the things, and alongside that, to process all this data after storage, I told, right, you will do some extraction using Data Factory. So what you will do? You will connect to some system using Data Factory. You will pull the data and you push it into one lake. Okay. Now inside one lake, now it's EL is done. Extraction is done by Data Factory. L means load. In storage is done in the one lake. Now EL is done. Now third steps come T, transformation. Transformation is done on top of this Lakehouse and warehouse data using Apache Spark. Apache Spark is one of the major, framework, big data framework, okay, which is used in most of the data engineering projects in current market, which is present currently inside the Lakehouse. Lakehouse, you will be able to do all the operations using Apache Spark notebooks. Okay, but warehouse is a SQL engine, right? There is a SQL engine. Everything has to be worked with the SQL. The SQL structured query language, you have to do everything with SQL. But in Lakehouse, able to work with SQL as well as PySpark code. For real-time analytics, event house and event stream is there. Like these are the things which is present inside Fabric, which you will be able to directly connect to the real-time systems. Okay, like sensors or the CCTV cameras or multiple things, multiple types of real-time sources are there. Those you can just connect using this tool and you will be getting the data at a near real time inside Fabric only. And for reporting like Power BI will be used for all the reporting related requirements. Those are also present here. Any question here? So it's just whatever I just told the earlier slides, like what is Data Factory and Dataflow Gen 2. Data Factory and Dataflow Gen 2, the major difference is Data Factory can only do pulling the data sources and pushing into one source, another place. It's just kind of a like transfer the data from one place to another. But Dataflow Gen 2 can do the same thing. Alongside, it can do some transformation. It can change the data at the time of transform. Major difference. Okay, just a simple term I am just telling. But both tools low code. Low code means you don't have to write a any kinds of Python or SQL, any kinds of code. It has some small query language very minor. So there you have to little bit of it is not a code, I can say. That is why it is called low code. It's not a no code. It's low code. So already I discussed Lakehouse and Warehouse. That Lakehouse and Warehouse both works on top of one lake storage. But Lakehouse is having another level of capability which Warehouse doesn't have. That is distributed computation. And this distributed computation is works on top of Apache Spark. Okay, and this Apache Spark is, we are working with the PySpark here. PySpark is another kind of framework on top of Spark only to write the code in a Python syntax. So using that methodology, we use the Lakehouse here. Majorly in Fabric world, majorly people use Lakehouses. Warehouse is used, but it's very minimal. So now comes to another level of topic which is not related to Fabric. It's a in general concept which is called medallion architecture. Now I am describing in Fabric, but this medallion architecture is not only for Fabric. It is applicable for any kinds of data engineering related projects. It is present in AWS, it is present in GCP, it is present in Snowflake, it is present in everywhere. But currently medallion architecture I am going to discuss here in the Fabric. So medallion architecture is a kind of architecture which shows that for any kinds of transformation, that ELT approach, the transformation will have 3 layers. The T, I said that ELT, the last T, is having divided into 3 steps. One is called bronze, another one is called silver, third one is called gold. So once the data gets landed into the storage layer, the cloud platform, then whatever the data is landed in the cloud layer with the replica of the source system, which is called a bronze layer. That is what it is written as raw data. Raw data means whatever is data present in the source system, the same data, exact same replica will present in the cloud, in your cloud layer. That is called the bronze layer. Silver layer is a clean and refined data. Like we do some cleansing. Cleansing means, let's say there is a data which is having some null value, but as per the business requirement, that data should not be having null value. So those kinds of record we drop, we change into some other data, or we drop those data. Those kinds of data, operations we do in the silver layer. You can see it's another type of layer. Okay. And third thing is gold layer, business level aggregation. Like after doing the cleansing, we have to do some transformation. We have to make the data valuable for the business, right? That is the major goal of the business. Why companies are using the Fabric medallion architecture. So in the last layer, why it is called gold? Because from this layer, whatever the data is present, from their business is getting some value. So we are doing some transformation, and we are making the data in a format where business can consume that data. Okay. So in this T, ELT, the T term is divided into 3 layers. One is bronze, which is called raw data, which is exact replica of source. Second layer is silver data. It is not exact to the source data, or the bronze layer, not exact to the business layer. It is just a kind of cleansing done. That is why it is called silver. And once everything is cleansed and once everything is transformed and making ready for the business, that is why it's called a gold layer. This is the whole concept of the medallion architecture, and this architecture is followed inside Fabric also. So now, as I already told, so for doing all the Microsoft Fabric analytics, we followed medallion architecture, we followed Spark, we followed data factory, everything we have done. Now the use case at the end, what is the goal from the Fabric? Is creating some dashboards. Like majorly the Fabric platform is machine learning algorithms it can run. It can do real-time fraud detection also. Like we have used that real-time analytics, like event stream, event hub also, right? So those things we have done, but the majorly Fabric platform is for the dashboard building. Like Databricks is a platform which is majorly for the machine learning, majorly it's for AI related purpose. Similarly, Fabric is also capable of everything, but it is majorly for the dashboard. So in most of the market, if you go to any kinds of Microsoft Fabric project, you will be able to see that There at the end, business is consuming it from the report. So the major use case for the Fabric is dashboard, but Fabric is capable enough to do real time, data analytics also, as well as it can do the machine learning. It can run any kinds of machine learning and AI, also on top of Fabric. Okay, so now coming to the summary and takeaways. Like for Fabric or any kinds of, which will definitely come in the market in coming days also. But on top of this tool, the major foundational thing is the data engineering, which requires a programming concept of SQL and PySpark, majorly nowadays. Okay, and the platform can be anything. If you know these two things, SQL and PySpark, you can work on any platform. You can work on AWS, you can work on Fabric, you can work on anything. But that is why data engineering concept, middle line architecture concept, data engineering, and all this SQL and PySpark, these are the foundational things for this data engineering related, any kinds of data engineering related courses. And Fabric is helping us to do all those data engineering related stuffs here. This is really a future ready tool in the modern data world. Any questions here? So I will be majorly teaching one, SQL, teaching you the PySpark. I'll be teaching you the data factory. I'll be teaching you the Lakehouse, warehouse, everything. I'll be teaching you the, what is that? Semantic models. I'll be teaching you how to design a data analytics platform. And I will be teaching you the CI/CD also. And I will be teaching you just like till the semantic model part. Power BI, I am not expert. I don't know Power BI. So I cannot teach you the Power BI part. I can just teach you the data engineering related. What are the components like data factory, Spark, data warehouse, Lakehouse, and then data flow Gen 2, and then semantic models, these things majorly.
Okay.
Any doubts or any questions here? Or did I miss anything? I don't think I missed anything. No, these are the things, yeah.